Hi everyone, I'm Cheryl. In this problem, we're asked to find the unit tangent vector to my position curve 5 cosine ti plus 5 sine tj when t equals pi over 3. Let's begin by getting the unit tangent vector. So if I want the unit tangent vector at any point, what I can do is find the derivative of my vector valued function. Now this gives me a tangent vector, but if I divide that by the norm of r prime, I guarantee that it's a unit vector. Okay, so let's go ahead and take a look at this example. I need r prime. So the derivative of 5 cosine t is going to be minus 5 sine t times vector I, and the derivative of 5 sine t will be 5 cosine t, and that's times vector j. I'm going to divide this by the norm of that vector. So I'm going to have the square root of the sum of the square of the components. So negative 5 sine t squared will give me 25 sine squared t, and then I'm going to add that to the second component squared, which is 25 cosine squared t. The numerator remains the same, minus 5 sine ti plus 5 cosine tj. And notice what happens in the denominator. I can factor out a 25, and I have the square root of 25 times the quantity sine squared t plus cosine squared t. Sine squared t plus cosine squared t is 1, and so that denominator becomes just the square root of 25. So I have minus 5 sine ti plus 5 cosine tj all over 5, which further reduces to a minus sine ti plus cosine t times my vector j. So that's my unit tangent. Now I want to find out what happens specifically when t equals pi over 3. So what happens when t is pi over 3? So I'm going to have minus the sine of pi over 3 times vector I plus the cosine of pi over 3 times vector j. Well, the sine of pi over 3 is minus square root of 3 over 2. So minus square root of 3 over 2 times vector I, and the cosine is 1/2. So that's 1/2 times vector j. I hope that was helpful. Thanks.